I am the Philosophical Bachelor, and today I want to talk about my metaphysical investigations. This is a book-length work that I had just completed, divided into 6 chapters. So it will take several videos for me to record the entire proceedings. Chapter 1: Introduction. The universe is the totality of everything, though at first there was simply nothing. In nothingness, however, is the potentiality for everything. Every logical possibility is latent in it, and can only be latent in it because it is nothing. If nothing was not nothing, but already something, then whatever is possible will be limited to the path-dependent possibilities leading from those things. But because there was nothing, every possibility remained possible. In addition, because there was nothing, nothing is unbounded, since there was nothing to bound it. Following Benedictus de Spinoza's reasoning, this must mean that the void is infinite, since it is nothing and hence is unbounded. However, nothing does not remain as nothing. Because 1 plus minus 1 equals to 0, quantum field fluctuations in the void allow pairs of virtual particles to manifest. A pair of virtual particles comprises a particle and its antiparticle. Matter is conserved because in each pair of virtual particles, each particle emerges together with its antiparticle. Because they are oppositely charged, when they touch, they annihilate, releasing energy back to the quantum field from which the pair first borrowed the energy from the field's fluctuations in order to come into existence in the first place. Hence, energy is also conserved. The void returns momentarily to its state of nothingness, but does not remain that way for long, since pairs of virtual particles are continually flitting in and out of existence all across the void. Some virtual particles manage to escape annihilation to become real particles. These particles lead to larger particles such as protons and neutrons, which then form the nucleus of atoms. When real particles exist, the void is no longer a void. The void has become space. Space is infinite because space is simply the void which has been annihilated because it is no longer void. Caused by quantum field fluctuations, these pockets of quantum activity are precursors of worlds. These fluctuations are the effects of randomness. The universe is space and the contents of all worlds. All the various worlds are just so many trials, so many particular ways of doing things. All worlds have matter because otherwise they will just be empty space and hence not a world. At first, this matter is only subatomic particles such as quarks, photons, electrons, and protons. Some of these electrons and protons form hydrogen atoms, which may then undergo fusion to become heavier elements, generating more and more energy to eventually become stars. These stars then cast off its matter, which cools to form planetary bodies. Because there is matter, there is motion. The motion can be at the subatomic level from nuclear forces, at the atomic level from electromagnetic forces, at the macroscopic level from gravitational attraction and mechanical forces, and then at the galactic level from the curvature of space-time. The continuous motion of matter from the subatomic to the galactic scale sets the stage for the possible. Atomic interactions lead to molecular compounds and chemical decompositions. Collisions between celestial bodies lead to the formation of other celestial bodies. Stars grow, go supernova, and collapse, some leading to black holes. Worlds are full of movement, each with different movements. In addition to the different movements, the conditions leading to the establishment of each world differ, with different fundamental physical constants leading to different subatomic, micro, and macroscopic interactions. All worlds contain motion and are themselves in motion in space. Because space is immense and the conditions for virtual particles to become actual particles are hard to fulfill, most worlds are so widely separated that their light may take tremendous amounts of time to cross the vast distances between worlds. We may hence never know of them. Some worlds will have the right conditions to foster organic life. Firstly, the fundamental physical constants must be in the range suitable for atoms to form, for chemical reactions to take place, and for energy to propagate. Then there must be sources of energy such as stars. These stars must neither be too few nor too many, neither too massive nor too small, in order that a solar system can form. Then whatever planetary bodies of that solar system must be of the right distances from their star, so that their temperatures are neither too high nor too low. The right chemical elements must be present. The list of conditions go on and is long. The many conditions must intersect, creating a sweet spot or zone of mathematical inequalities expressing the range of conditions suitable for life. However, even with the existence of a sweet zone, there is no guarantee that life will emerge in it. Even if life emerges, there is no guarantee that it will persist. However, given the mathematics of infinity, where infinity times delta equals to infinity, delta representing a small non-zero possibility, whatever is logically possible will at some place and some point in time happen. One of these places is the world where the Big Bang happened. From nothing came a series of events that led to a singularity, which then brought about the Big Bang. We often term that event as the beginning, as the event from which we begin to mark time, but it was not the start of time. It was also not the start of space, because before the beginning, there was already the void. From observing the redshift of distant supernova, which is how the light the supernova emits stretches as they recede from us, we know that our universe is expanding. To avoid confusion, I reiterate my usage of technical terms. The universe is the totality of all worlds and space, and what we usually call our universe is more correctly our world. This ongoing expansion implies that if we mathematically reverse the process, going back in time all the way to the beginning, all that exists must have converged until they were all compressed into a single infinitesimally tiny point, smaller than a proton. Then at the moment of the beginning, it rapidly expanded in a massive blaze of energy. It then began to cool, allowing elementary particles to form, after which these particles combined to give larger particles such as protons and neutrons, which later fused to form atomic nuclei. This beginning took place 13.8 billion years ago. The Big Bang is a neat story supported by astronomical observations from our most powerful telescopes, both land-bound and in orbit, both optical and radio. The data from these observations, when fed into Albert Einstein's theory of general relativity, is how we are able to calculate when the Big Bang happened, give or take some 21 million years. However, did the singularity really exist? In this singularity, matter was infinitely dense, energy was infinite, and space-time was curved so tightly that it was just a single point. Or is this singularity just a mathematical artifact where the theories and equations of physics break down, revealing the limitations of our scientific knowledge, outside of which we can only speculate? However, even accepting the Big Bang theory as it stands provokes further questions. Why was it that exact moment 13.8 billion years ago and not some other time before or after that? What was there before the Big Bang? Was the Big Bang truly the very beginning of everything, or was there something already existent before that? If there was something before the Big Bang, when did that something begin? What is the universe expanding into as it expands? To examine these questions, we will consider the role of randomness and what nothingness or the void means. But how can we know if we are right? According to David Hume, there are only two sources of evidence that can justify our theories: our use of reason and our experiences, leading to relations between ideas and brute facts, respectively. Relations of ideas do not require empirical confirmation. We do not need to go and measure triangles in the real world to check that their angles add up to 180 degrees. Besides, that will be futile since there exists no perfect triangle in the physical world. Reasoning starting from definitions and using pure reason suffices. Likewise, from pure reason alone, we can understand that parallel lines never converge. If we had to depend on empirical confirmation, we will have to follow two parallel lines for all eternity just to check that they do not cross. Relations of ideas are governed by logic. If we reason that parallel lines never cross, then by the logical principle of non-contradiction, we also know the opposite, that parallel lines do cross, to be false. However, relations between ideas cannot tell us everything. No amount of reasoning will tell us the average age of people in Singapore or the height of Mount Everest. We only know these facts because someone had gone and taken census data or measured the height of the mountain. We do not have to do it ourselves, but instead rely on the accounts and expertise of those who did the work, and so the experience referred to need not be our own personal experience, but some other person's. In addition, for many instances of knowledge, it is a combination of reason and experience, since we are unable to make a direct measurement. To find the average age, we will first have to collect the raw data of the individual age of people in the country, and then apply to this data techniques of reason, such as statistical mathematics and logic, summing up all the individual ages of those in the population, and then dividing the result by the population size. Similarly, when measuring the height of Everest, we are unable to take a really big ruler and prop it up next to the mountain. Instead, we have to use, for instance, the difference in pressure at the peak from sea level to work out, using the barometric equation, its height. A similar method was employed to figure out the age of our world. Observational data of the redshift of supernova were imputed to Einstein's equations of general relativity to work out the answer. However, these two sources of knowledge still leave a lot unknown. For some of these unknown, information gathering efforts may allow them to become known. For instance, we currently do not know the number of grains of sand on Siloso Beach, but if we are interested to find out, effort can be made to count them all up. For some of these unknown, in addition to information gathering, we also need advances in science and technology. For instance, to cure cancer, we need to know more about existing cancers, but also require advancement in surgical techniques and medicines to treat them. However, even with information gathering and advancements in science and technology, there remains a sizable amount of knowledge that is unknowable even in principle. This last category spans a wide range of questions. We do not know, at the present moment, what my heart rate will be at 12:24 p.m. next Tuesday. We can only find out next Tuesday at that time by measuring it then. This example is trivial, but there are many similar questions whose answers for most people are unknowable in the present, though they will be very interested to know what the answers are. For instance, the time or place of one's death. If only we knew, we can plan ahead so as to distribute our assets, spend our final hours with loved ones, or in the case of the servant of the Baghdad merchant in the appointment in Samara, and the father of Oedipus, to take preemptive measures to avoid their doom. Nonetheless, such unknowable knowledge still only concerns a small group of people, if not merely individuals. What this essay is interested in investigating are questions of cosmological importance, such as the questions concerning the origins of the universe as posed above. What we know about the Big Bang and the cosmos cannot tell us for sure whether there was something prior to the Big Bang and what that was, why that exact moment and not before or after. We have no way of using only pure reason, experience, and their combination to arrive at answers for these questions, making these answers seem beyond the possibility of knowledge. Yet, because such knowledge is important to us, to our self-understanding of our humanity and our place in this world, we can only do the next best thing, which is to speculate. Speculation has a long storied history since the human species acquired the ability to wonder about things. Prior to the start of philosophy in the West, around the 7th century before the Common Era, people turned to poets like Homer and Hesiod for explanations. These poets spun fantastic stories of gods and their deeds, which are superb acts of imagination, but stories nonetheless. Though these stories can explain everything, they are unable to predict anything. Yet, myths are important precursors to our later, more concerted drive to understand. Aristotle tells us that even the lover of myth is in a sense a lover of wisdom, for the myth is composed of wonders. In the face of our impotence to understand, we invent. Has philosophy been able to do any better? Up to the scientific revolution starting in the 16th century in the Common Era, with Nicolaus Copernicus, philosophy was considered the only body of knowledge. People like Isaac Newton and Adam Smith regarded themselves as philosophers. The origins of science and mathematics are philosophy. Physics and its method of observation trace back to Aristotle. His physical theories were the orthodox theories of science until the scientific revolution and even for a few centuries after it commenced, dominating our scientific understanding of the universe, physics, and biology. Today, the domain of philosophy has shrunk, leaving it primarily with the metaphysics of the unknowable, method in epistemology, logic, the philosophy of language, and the philosophy of specific disciplines, including the philosophy of science, philosophy of the specific sciences, and philosophy of art. Philosophical work also continues in ethics and politics, which does not yield to the scientific method given the inexactness of human conduct vis-a-vis society. In these remaining fields of philosophy, the questions they investigate permit no easy or exact answers. Those questions that do have exact or semi-exact answers have become their own fields of study, such as the sciences, mathematics, but also economics, political science, psychology, and sociology. The philosophical method tends to be discursive, where plausible theories are proposed, critiqued, refined, and compared, with no definitive answer possible, since they are probing the unknowable or the indefinite. This lack of certainty is not unique to philosophy. As the exact sciences advance, they also venture into the realm of the speculative. The hallmark of science is empirical verification, yet theories such as superstring theory in physics may be outright untestable and hence unverifiable. Indeed, such advanced work in the sciences seems closer to metaphysics than to physics, because it is trying to probe what underlies natural phenomena. Arthur Schopenhauer defines metaphysics as any cognition that claims to go beyond the possibility of experience, which is to say, beyond nature or the given appearance of things, in order to disclose something about that which in some sense or another conditions appearance, or in common parlance, about what is hidden behind nature and makes it possible. Science investigates phenomena, while metaphysics investigate what makes the phenomena possible in the first place. If what makes phenomena possible is itself another phenomena, the question will be what makes that prior phenomena possible, giving rise to an infinite regress. What halts the regress is to understand that what ultimately grounds phenomena or nature is not phenomenal. Since it is not phenomenal, the methods of science hence cannot work, since experiments and empirical observations can only investigate phenomena, but not what is not phenomenal. This is why metaphysics is a speculative endeavor, though what it proposes has to agree with phenomena, which means it still needs to relate to scientific theories and nature. Nonetheless, even though metaphysical theories cannot be proven, we can assess them based on meta-criteria, such as whether they aid our understanding of reality and of ourselves, whether they are coherent and comprehensive, bring a harmony to the profoundly heterogeneous appearances of the world. In brief, the question will be, does it make sense given what we do know of the world? In what follows, I will attempt to provide a coherent metaphysics that takes into account contemporary scientific ideas and theories. I am not a scientist. I try to get the details of the science right, though my sources are often encyclopedias and reputable popular science publications, since they explain the issues in accessible language. Nonetheless, we should take note of two methodological points. First, scientists themselves do not have a consensus in some areas of science, such as cosmology, quantum theory, and the origin of life, areas which I refer to extensively in this essay. They work with competing theories since they do not yet know which is right. They do not have answers to the questions I am tackling in this essay, which is precisely why this essay is being written. I am of course in no position to adjudicate which is likely more correct. I note competing positions, though I will discuss some positions at greater length than others. Secondly, a problem with philosophical theorizing that depends on science is that scientific theories themselves are debunked over time. Hence, my metaphysical theory aims not to be reliant on which scientific theory is right, or even any of them. I discuss scientific theories primarily to demonstrate that my theory is not divorced from our contemporary knowledge of reality, be it scientific or metaphysical. However, whichever scientific theory prevails, even ones not mentioned here, including future ones, my aim is that my philosophical point still holds. On that note, let us proceed with my proposed cosmological metaphysics. In subsequent chapters, I will build from it to talk about the metaphysics of life, consciousness, and finally, spirit. Thank you for listening to the Philosophical Bachelor.